Here we have the notes for solving exponential equations with a common base. So that's one of two solution methods we have available to us. So exponential equation can be written with the same base on each side. It's possible to solve by setting the exponents equal. So if your bases are the same, in this case a, we have expression in the exponents, then the exponents must be equal if the bases are equal. One thing that will be helpful is this little table I made up. So you have your base down here, your power down here. So these numbers represent, like, so 5 to the third would be 125. It'll be helpful for finding common bases. This will be attached on Google Classroom. Okay, so pretty much our goal is to try to write the bases as the same thing. Usually you want to start by trying to write the larger power, or a larger base, as a power of the smaller base. I'm going to try to write 625 as a power of 5. So to do that, I can come to my table, base 5. So I'm going to write across 625 is 5 to the 4th. So I can rewrite this equation. We're going to place the 625 with a 5 to the 4th, 2x. So then we have the product, or the power property for exponents, where if you raise a power to a power, you multiply them together. 5 to the 8x. Now, because my bases are the same, I know that my exponents must be the same, so I can just pull the exponents out separately and solve. So I'll bring the 3x across. So subtract it and divide everybody by 5. So the solution would be x is 0. All right, so for this one, we need 8 as a power of 2. So go to our row for 2, read across. 8 is 2 to the third. So I can rewrite that. So this 2 to the x minus 4. 8 becomes 2 cubed to the 4th. So use your exponent properties. That makes this 2 to the 12th. Once your bases are the same, we can set the exponents equal. So add the 4 across would give me 16. Divide by 2 would give me 8. All right, so 3125 is a power of 5. So 5 to the 5th. So 5 to the 3x minus 1. Place that with 5 to the 5th. 2x plus 4. Now on that right-hand side, we have to be careful because this interior 5, the power is going to distribute. So it's going to be 5 to the 10x plus 20. So pull our exponents. So if we bring our x's left, it gives us negative 7x. We send the 1 to the right, that gives us 21. So x would be negative 3. All right, so 4 introduces a fraction here. So fractions just have negative powers. So I need to try to write, so 81 is technically the smaller, so we need to try to write 243 as a power of 81. Well, our sheet does not go up to a base of 81, so we probably have to write both numbers as the power of the same thing. So what I want to do is I want to look for a row that has both 243 and 81 in it. So there's 81, but no 243 on the row for 9. Where else is 81? There's 81 with 3, and there's also 243. So 81 is 3 to the 4th, 243 is 3 to the 5th. So this becomes 3 to the 5th to the 4x plus 12. And now this 1 over 81 becomes 3 to the negative 4th. So negative exponents are how we denote things that were fractions. Distribute our power, so 20x plus 60 equals 3 to the negative 20x minus 12. So our exponents can be set equal to each other. Oops, 20x minus 12. So if I bring the x's to the left, it gives me 40x. Send the numbers to the right, negative 72, and then do my division. So negative 72 divided by 40 is negative 1.8. Or if you want the fraction, that is negative 9/5. Okay, so 64 is a power of 8. It's 8 squared. So some of these you may know just off the top of your head, and that's fine. You don't need to go to the table every single time. So 8 to the x minus 2 equals 8 to the negative 4x plus 4. So pull our exponents. So 5x equals 6. So x is 6/5, or if you want the decimal, 1.2. Okay, so 8 is a power of 2. It's 2 cubed, but since it's on the bottom, we're going to have to use a negative exponent. So I would have this. So 2 to the 12x minus 6 equals 2 to the negative 2x squared minus 16. So 12x minus 6 equals negative 2x squared minus 16. So in this case, we have a quadratic because of the x squared term, so we need to move everything to one side. So I'm going to bring everything to the left because that's actually going to make my x squared positive, then the 12x, and then it's going to be plus 10. Now, the one thing to notice is all of these coefficients are even, so if I wanted to, I can divide everything by 2, and that makes my math a little bit easier. So I'm going to solve by factoring. If you want to do the quadratic formula, that's also fine. So two numbers that multiply to 5 and add to 6 are 5 and 1. And remember, your solutions are the opposites of your factors. So this equation actually has two solutions, negative 5 and negative 1. All right, so one last one here. So 64 is 8 squared, but since it's on the bottom of the fraction, it becomes 8 to the negative 2. So we would have that. Do our power rule on the right, so 8 to the positive 4x minus 144. Pull our exponents, negative 2x squared plus 2x equals 4x minus 144. Now in this case, I'm going to move everything to the right because that's going to make this x squared term become positive. So x squared plus 2x minus 144. Once again, all even, so I'm going to go ahead and divide by 2. X squared plus x minus 72. And then factor. So I need two numbers that multiply to negative 72 and add to 1. So that would be positive 9 and negative 8. And your solutions are the opposites, so negative 9 or positive 8 would be the solutions. And that brings us to the end of the section.